Welcome to Aerial Services LiDAR 201, the first of 3 webinars in the Aerial Services 2013 Fall Webinar Series. This is your host, Joshua McNary, Director of Corporate Development at Aerial Services. We are pleased you have joined us and hope you walk away having learned more about how to use LiDAR for your geospatial applications. But first, a few housekeeping notes. 1. You may ask questions via the questions pane on your screen. We'll collect these questions for responses from the speaker at the end of the presentation. 2. We want your feedback. Contact us via the chat pane or via the post-webinar survey with any ideas, suggestions, or concerns regarding the webinar. 3. The post-webinar survey will appear on your screen after you leave the session. Please use that as an opportunity to share your feedback. 4. Lastly, but not least, note that Aerial Services will have 2 other webinars this fall. Join us October 23rd for the Key Points to Maximize Your Geospatial Data Project webinar and November 13th for the Web Mapping Solutions Technology and Tips webinar. Visit www.aerialservicesinc.com/webinars for more information and to register. I'm now pleased to introduce my colleague and friend, Aerial Services Business Development Director, Chuck Boyer, who will share his expert knowledge with you today. Chuck has over 15 years of successful experience in consulting and customer service. Before becoming the Director of Business Development, he was the top regional sales manager for a prominent geospatial solutions provider using LiDAR technology. Prior to that, he had been recognized as a top channel partner manager at a major computer company. He was hired by Aerial Services because he can build long-lasting relationships, exudes professionalism, has integrity, and knows what it takes to get the most out of LiDAR. So without further ado, I'll pass the baton on to Chuck. Chuck?
The webinar. Thanks, Josh. When we do these kinds of seminars or webinars, I've done the LiDAR 101 just hundreds of times. But the big question that comes up people have is, okay, I have the data, what do I do with it? So that's what we're going to attempt to show everyone. Our agenda today is going to be going over LiDAR Basics. We'll talk about why LiDAR. We'll talk about the accuracy of LiDAR, the process and the equipment that we use. We'll talk about some definitions. We'll go into LiDAR markets and how LiDAR can benefit people in those particular fields, and then we'll answer any kind of questions. The LiDAR Basics. LiDAR is an acronym. It's just light detection and ranging. What LiDAR is we take a sensor in the air, either in a helicopter or an aircraft. It can be done mobily as well. We have a GPS in the aircraft, an IMU or an inertial measurement unit in the aircraft. There's a GPS on the ground. And then we have the LiDAR sensor that shoots beams of light into a rotating polygon mirror and puts up to 300,000 points of light on the ground per second. Each one of those points has to triangulate with one of the 6 satellites, or a minimum of 6 satellites. Aerially, we do 300,000 points per second. Mobily, they're able to do 600,000 points per second or more, just depending on how many sensors they're using. The density in LiDAR, we can do anywhere from 2 to 100 points per meter. Mobile, they can do, just depending on the number of sensors, 2,000 to 500,000 points per second. And what we're going to be able to collect is a point cloud of data, and that point cloud goes into a file. What LiDAR is, it's the most cost-effective approach for any kind of large or small mapping area, whether it's a large block or a corridor. It's a very dense 3D coded detailed product. It's going to be an integration of using the LiDAR, and we can combine that with photogrammetry. The biggest thing about LiDAR is you collect it once and you use it many times. So you don't have to send out people for subsequent surveys. You got the entire area at one time, and then many people within the organization can use that very same data. This is an example of a point cloud of data. As it shoots down, we can see the tower, we can see the road, the trees. Why LiDAR? Because it's cost effective. We're able to collect that data once and then use it many times. We're able to collect it, process it faster than you can in a traditional ground survey project. So it's going to be critical for those planning decisions. One of the issues that people have is that they want the LiDAR collected right away, then they want the data as soon as possible. LiDAR is going to be able to provide that. In colleges, they teach a scenario where the guy who orders aluminum, if he didn't collect it or order it correctly, then there's going to be no beer at the Super Bowl. LiDAR is going to be the same way with a project, on a pipeline project. If someone's ordering pipe, the worst case scenario is that the pipe is sitting there waiting for people. The other is that people are sitting there waiting for pipe. So to be able to dictate that workload faster is going to be paramount to the success of any project. There is no impact on an environment. I've never heard of a LiDAR operator getting shot at when they're flying over an area, but I have heard of surveyors getting shot at because they let the gate open and 1,000 head of cattle walked freely. So we're going to increase your productivity in any kind of heavily forested or difficult terrain because we can actually fly over it where it may be next to impossible to get a survey crew with all their equipment into that heavily forested or difficult terrain. The less man hours in the field, the safer it is, and anybody has to like the project when safety is a big concern. We're going to be able to provide a complete and accurate data set. We're going to avoid those intrusive or multiple surveys. And LiDAR, you can collect it in the summertime, you can collect it in the wintertime. The only thing you really can't do is you can't collect in the rain, you can't collect in the snow, but those are elements that just are irrelevant to the survey. What is accuracy? I've talked with a lot of people, and when we go to get this kind of definition, it's always easier to put people on the same page when you're talking about something. So we'll talk about map accuracy, and the map accuracy is the closeness of results of observations, computations, or estimates of a graphic map feature to their true value or position. Now, when measuring that, we have the absolute accuracy. So absolute accuracy is if I have a telephone pole, where does that telephone pole exist on the face of the earth? Then there's relative accuracy. So it's taking that telephone pole on the face of the earth and then adding 15 other telephone poles or other kind of features, and how do they compare to the accuracy of each other? With LiDAR accuracy, I can be within 1 to 3 inches on a hard surface. I can be 2 to 12 inches on soft or vegetated surfaces, a rolling terrain. I can be 5 to 15 inch accuracy on a hilly terrain. Those are on the vertical accuracies. In the horizontal, I can be anywhere from 3 to 30 inches on all but extremely hilly terrains. And so the questions come up, why the big delta between 3 and 30 inches? When you look at the slope affects the accuracy. If you look at the image on the right, we're shooting a laser beam. The laser beam is like a flashlight. If you point it directly into a wall, you're going to have a circle. If you shoot it down the wall, the farther down the wall you get, the more ellipsoidal the beam is going to be. LiDAR is going to be the same thing. We also have an issue with scan angles. The LiDAR sensor that aerial services use, we can do up to a 60-degree field of view. So we can fly wider and penetrate the canopy than some other sensors out in the market. There typically are two seasons for LiDAR. They call them leaf on and leaf off. Because we're shooting a sensor that's 300,000 points per second, I can penetrate a lot of canopies where other sensors may not be able to. However, if I'm in a forest and I look up and I can't see sky, I'm not going to be able to penetrate the canopy either. For getting that accuracy, we use what's called control. So we'll set vertical control points and we'll set checkpoints. As the caption reads, you're as good as you think you are until someone tells you you're not. Knowing exactly where this point cloud of data exists is crucial to the success of the project. So I've got this point cloud. I've gone in before I start flying and I set these control points so I know exactly where they are. And then I'm able to set my LiDAR directly on top of those points, because if those 38 points are correct, then the rest of the survey is going to be correct. But I also do checkpoints, so I'm able to do ground truth verification to verify that my LiDAR was accurate. When we do the control, either we can set up control or we can use or tie into one of these cores, which is a continuous referencing station. We can also set up a real-time network, so we're able to get the assessment, the accuracy that we're looking for. With our LiDAR sensor and proper control, we're able to get anywhere from 2.5 to 4.5 centimeters accuracy. When you look at LiDAR alignment, we'll fly over and collect the data. With proper control, I'm able to pull these points of light into the proper alignment to get the image that I'm actually looking for. With the LiDAR process, I often describe it as it's like an onion. You use the layers when you want, when it makes sense. We fly and collect the data. We use a full waveform LiDAR sensor. The pulses have up to 15 returns. We're going to process the LiDAR. When we process the LiDAR, for every hour of flight, it takes us 30 minutes to post-process it to get it into a raw calibrated point cloud. Then we classify those points. We classify it as ground layers and above ground layers. The above ground features are trees, building towers, power lines, things like that. Then we create the products and the deliverables from that. We create the digital elevation model. We can create contours. When you speak of contours, this is another definition thing. Contours can either be a deliverable or it can be an accuracy. In delivering a deliverable, contours, we can deliver either cartographic or LiDAR contours. Cartographic are the ones that would typically be derived or thought of derived from photographs. They're really smooth and what most people are used to in looking at contours. LiDAR contours are typically real jagged and they're not as pleasing to the eye. However, the cartographic contours are based on a point every 20 feet, and the LiDAR contours can be 20 to 40 points per meter. So they can be jagged, but they're very, very accurate. We can also create vectors. We can create fly-throughs. So what we're able to do is take all of this data, we collect it once, and then there's many ways that we can use it that's beneficial to customers. You look at the LiDAR that we collect. We have the classified point cloud. Then we do the contours. We can create a triangulated irregular network or a TIN off of that. We can look at the hillshade intensity, which looks like a black and white photograph. We can output that into a GeoTIFF format, so now all the points are georeferenced. We can do the planimetrics and building model, and then we can take the orthophoto and orthorectify the photography to the LiDAR. on a typical workflow on a project, we set the ground control, we do the flight survey, and then we either do the aerial photography or the LiDAR, working towards the same end delivery of the delivery of products, just depending on the actual process that you're looking for. With the LiDAR, we have about a 5-step process for QA/QC for the collection of data and a 7-step process for the QA/QC of the actual data that's output, to just assure our customers that everything that we provide has been looked at by somebody. It's done step by step. There is a methodology that what we use, so we assure our customers of getting good data. We guarantee 100% of our data, so if there's something that we collect, sometimes a contractor will read 95% accuracy. And then if you're using other vendors, you can say, well, I found this error, and they'll say, well, that's part of the 5% I'm allowed to have, so you still have to pay me. At Aerial Services, if there's something that we should have collected that we didn't, if we have to, we'll go out on our dime and collect the data. We want to just assure our customers that their 100% satisfaction is our goal in mind. The equipment that we use, there's a couple of different kinds of sensors. There's an oscillating mirror. The oscillating mirror works in a zigzag pattern. When you think of a pendulum swinging back and forth, that's basically how the oscillating mirror works. So it's going to derive its data, like I said, in a zigzag pattern. The problem with it is that it can slow down and then stop to change directions to come back the other way. Sometimes that creates bad data, so a vendor may take bad data and then label it or put it on top of the other bad data, so they'll do a 10% overlap and trim the edge. We use a rotating polygon mirror, and our rotating polygon mirror is going to output data in just a straightforward pattern. It's going to do a 60-degree field of view, providing 300,000 points on the ground per second. We use what I described as a full waveform LiDAR, so we're able to not only, when I first started in LiDAR, they were using 20 kilohertz sensors. Now we're using a 300 kilohertz sensor. Being able to do 1-foot contours at 3 to 4 points per meter could be very difficult. Now we're able to do 20 to 40 points per meter. Used to be that you would only get first and last return. Now, because I'm using the full wave of data, not only do I get the first return and the last return, but I get everything in the middle. So I'm able to get pulses on the way down to get all the vegetation. So that's why it's not as much of an issue with leaf on and leaf off. I have done projects for the Army Corps of Engineers and done projects in August which would have been leaf on, and being able to get where tributaries are flowing into streams, flowing into rivers, and being able to map that with intense accuracy. When you look at data collected, some people want to know what the difference in a single pass or a double pass. You just collect a lot more points. You can collect in a transportation project where a mobile scanner is going to do 600 to 1,200 points. I'm not going to be able to collect that many points, but if I flew a double pass on an area for specific issues, I could collect up to 80 points in a 500 to 1,000 foot swath. Some other project definitions that we'll look at. When you look at bare earth, it's typically what people want delivered in a LiDAR project, all the points collected by the LiDAR sensor, and then it removes all the ground surface as if there's no vegetation, building, or other man-made structures. It's just a subset of the point cloud. And this would be an example. It's color-coded based on elevation. The point cloud or mass points is just collecting everything and then classifying it. So you can see the vegetation, you can see the buildings, if there are any roads, it's all in the actual LiDAR point cloud. The triangulated irregular network, or a TIN, is a data structure used in geographic information. It just represents a surface. It's a vector-based representation, and it brings in the X, Y, and Z coordinates, and all the points in between are interpolated. So this would be an example of a TIN. Now we look at the building footprints. It's just a polygon that has the outline of the building. We can look at contours at 1 and 2 foot contours. They're just LiDAR derived on 1 and 2 foot intervals. And we can do also an indexed contour. And the indexed contour would add every fifth line would be a different color, just so you can denote the difference. This would be an example of the contours, the purple line versus the blue line. The digital elevation model. I can sit down with the leaders of the industry and I can ask them for a definition of a digital elevation model, and I may get, and 3 different people, I could get 3 definitions. So just to make sure that we're all on the same page to aerial services, it's a model of the bare earth surface that has a regularly spaced horizontal grid, each with an elevation. And right now we're creating DIMs with a 1 and 3 meter grid pattern. This would be a digital elevation model. The digital elevation model can be created with LiDAR, or it can be created with photography. Now we'll look at hillshade or shaded relief. The image that I have is a 3 meter. It's just a raster data set. And it's going to mimic the sun shining on the terrain, so it's easier to see the relief. The different colors are elevation. Then we have something called break lines. A break line just shows a significant change in the smoothness of a surface, such as abrupt elevation change. A hydro break line just shows the outline of a stream or a lake or a river. This is an example of the break lines. When you look at vectors, the image on the left is a photography. The image on the right is based on the hillshade image. If you look there in the upper half, there's a white circle and then a red circle, and the red circle is outside. That's due to some of the building lean that you can get from aerial photography. With the LiDAR, it's picking up everything exactly where it's supposed to be. GeoTIFF is just a geo-referenced TIFF format image. You can do the hillshade either in a full feature or a bare earth. You can go back and forth and look at the image to see where the stream flows. People are asking us, can you do bare earth out of a point cloud in imagery? And I haven't seen where that's been able to be done yet. So it's taking that full feature and then eliminating all the points and making a bare earth model is very difficult to do other than using LiDAR. Another file format is LAS. It stands for Long ASCII Standard. It's a non-proprietary data format. There are multiple LAS formats from 1.1 to 1.4. The 1.4 is able to add in more data sets. It's really designed for power line usage and things where you're going to have a lot of different categories. When you look at an LAS file, the image on the right is 26 points per meter. The image on the left is 10 points per meter. So you can see how the more points you have, the better it is in the imagery. The LiDAR markets, there are a lot of them. There's infrastructure planning where people want building footprints, elevation data. They want transportation, either roadways or waterways, utility routing assessment, telecommunication modeling, parks, recreation planning, or emergency preparedness. The markets that we work within are the transportation industry, the mining industry, oil and gas pipeline, utilities or power lines, and defense and security. In the oil and gas pipeline, some of these examples are going to be real apparent to people, and others you're going to say, well, why didn't you talk about this or this or this? So this is just a brief outline of what's available, but we're not limited to what I'm showing you in these slides. In oil and gas, there's something called HCA, which is high consequence areas. A pipeline can't be within 220 yards either side of center of a populated group if it's a class 3 or class 4 high consequence area. So by being able to fly over and collect the surface model, we've also got partners that can do the depth of cover analysis and the pipe location, so we're able to mark that and georeference it. We can do, either with LiDAR or our partners that we've assembled, we can do the class location analysis, the depth of cover, a risk assessment. We can do a maintenance prioritization. You're flying once and using the data for the different groups within the company. So engineering needs data, operation needs data, the environmental needs data, the planning, civic, all of those people need data, but they don't need the same data at the same time. So with LiDAR, we collect it once and use it many times, as opposed to sending out people for these different organizations. We're able to create a fly-through, so a visualization for public support. And then it can easily integrate, what we provide can easily integrate into the software that companies are typically using, any GIS or CAD software. And then it facilitates the inspection. That's all before the project is finished. After the delivery, we can save companies millions of dollars. I did a project, 130-mile pipeline. We were able to collect using LiDAR, aerial photography, and ground truth, or ground survey for ground truth verification, cost somewhere between $300,000 and $500,000. We're delivering in 6 to 9 weeks. Ground survey would have cost about $1.1 to $1.2 million and would have taken about 20 weeks. So I'm delivering 13 weeks faster at a significant savings to the customer. That's on the front end. On the back end, I saved that company $2.6 million because they did not have to send people out for the subsequent surveys. So it is collecting it once and using it many times. For projects in electric transmission, there's a lot of different reasons to use LiDAR. We can use it on a green tree project. We can do vegetation analysis. In 2007, there was a random tree that hit a random power line and knocked out the entire eastern seaboard. So the government came up with NERC to say that trees, depending on the power line, have to be a certain distance away. So we can do that vegetation analysis. Even if everything is NERC compliant and you've got all the control set, we could go back and fly subsequent years just to determine where the vegetation is. We wouldn't have to do as many points in the ground as you would for your initial survey, but you're still going to be able to get the encroachment. So you can tell if Farmer Jones built a swimming pool near the power line. We can do inventory assessments. We can do as built versus as designed. A lot of companies with power lines want you to fly at the beginning of a project, and then after everything's put together, they want, and the last thing they want is it to be flown so we can verify that it was built as it was designed, or if there's any changes, they're going to be able to detect those in the survey that we provide. We can provide the orthophotos, we can provide the oblique imagery, and full motion video. This is an example of the power lines. We also do weather monitoring when we do the power lines. So with this weather assessment and the LiDAR on the sag of the catenary, if the power company will tell me how much power they're running through, I can tell them how much more power they can run through safely, or if they're at a danger at a brownout, just because of the sag of the line of the catenary. We can provide data that can go into engineering profile drawings for PLS CAD. Another industry that we work in is mining. We can do volumetric studies. We can do change detection and help with the transporting of raw materials. On the volumetric studies, I would fly an oil sands project or something that they're mining on the surface and fly this year and then next year and do a change detection for the volumetric study. The same can be done with levees, where if you had a 13-county area, flying that with LiDAR may not make sense every year, but flying the levees in that 13 counties to do change detection to see if they're holding up. Just the example of New Orleans, when the levees didn't hold up during the hurricane. This is all something, and LiDAR provides the what if to show you what can happen and the worst case scenario, and it's better to run computer models than have it actually happen to you. This would be an example of a volumetric study. In transportation, we can do right-of-way, we can do roadway or railway features and cross-sections. We can do the planimetrics. We can fuse the airborne and mobile LiDAR, and again showing the as-built versus as-designed. There's a toll road in Dallas that was designed a certain way, and they couldn't understand why a tractor-trailer going at a high rate of speed in inclement weather, they had a series of crashes, and so they had a GIS model showing all of these accidents at this particular location. So they went out and flew LiDAR on this project, and they found that as designed, it was a straight angle. As built, an extra angle was put in, actually causing these accidents. They went in one night, closed the highway, took out the angle, and the crashes stopped. So we're able to collect, fuse the data for airborne LiDAR and photography. We can do the cross sections and any of the roadway features with the LiDAR. We're able to do railway assessments. We can do the roadway planimetrics. It's really great to be able to take the mobile LiDAR, which mobile LiDAR is going to do 600 to 1,200 points per meter, but it's only going to go about 120 feet either side of center. So you get a really, really accurate assessment, but if the LiDAR hits anything, it can't penetrate through. Then we add an airborne LiDAR to it. So now we take that swath and make it anywhere from 500 to 1,000 feet instead of 120 feet. And then we bring the data sets together so you get the best of both worlds. I've shown you a lot of information. This is my contact information if you have any questions further. I am the Director of Geospatial Solutions. That is my phone number and my email address if you have any questions and you're thinking about the presentation, and Josh will show you how to get a copy of this presentation because it has been recorded. You're able to come up with other questions, or if you want to say, well, Chuck, I know you showed this, but could it do that? I sure welcome the opportunity to sit down with you. If you've got people in your offices, either one or one of our geospatial managers can come into your office and do lunch and learns or webinars just like this. We would welcome the opportunity to do that. Now I'd like to open it up to any questions.
Well, thanks, Chuck, for the presentation, and we just certainly would have some questions here that we'd like to address as we move forward for the rest of the time we have here today. And before we do get started with questions, I wanted to just make note that during the question period, we don't typically get overly project specific with the Q&A, but as Chuck noted, if you have any project specific type questions, we'll definitely get back with you after the session. The other item is you can always feel free to call us anytime after this webinar ends. We're certainly happy to address questions, even if you don't have a specific project need. We're here to help, and we put on these webinars regularly so that we can expose some of our knowledge to you and be a partner with you in your remote sensing and geospatial needs. So feel free to contact us anytime here at the office if you have questions going forward. So as we noted earlier on and in our chat during the webinar, you can feel free to use the questions pane of the GoToMeeting panel to send us questions at any time during the Q&A. But let's go ahead and get started. Chuck, we got a number of questions during the presentation, so I'm going to just shoot those over at you.
Great.
So the first one was came in when you were speaking about control and checkpoints. Could you explain the process of how we actually go about doing the targeting control and checkpoints? I think you addressed the importance of it and why we do it, but how does that actually happen? And for companies like us, how do we actually go about setting the control, typically?
The first thing we do is get an image of the project, whether it's a shape file or a KMZ file. So you would give me that information, then I would send it into one of our production people that are going to actually look at the control of the area. They'll tie into the CORS network, or they'll say we need points here, here, and here. If we're looking at a block area, it's going to be where we're able to actually put the control down with a corridor. Typically, we'll put 2 points on the front end, 2 points on the back end, a couple of points on either side, and then if there are, that would just be on a straight corridor, but we all know that corridors never stay straight, so we would typically put, every time the corridor bends, we would put a control point there.
Okay. Next two questions I think are semi-related. Question as to a little more detail on how we actually classify LiDAR points. I know you showed a number of slides that showed that process or discussed that process. And then the related question that came in just after that one was for how we go about doing that classification or working with LiDAR data. Are we using internal type software packages or some other off-the-shelf type softwares? And maybe you could speak to the pros and cons of those different solutions and then also how it relates to classifying the data.
We use MicroStation products we'll run it through, and we'll probably have algorithms that will be able to auto-classify, I would guess, somewhere between 80 to 90% of the data. There still is going to be data that we have to run through, and that's why it's imperative that your data is looked at by the processor 100% of the time. There are people out there that will look at 10% of the data, run it through these algorithms, and then ship out the data and fix problems as they're noticed. That doesn't sit well with us. We want to look at 100% of the data to verify that what we give to you is as accurate as possible. people that don't look at 100% of the data probably are not charging you a premium, so it's going to be cheaper to do it that way, but at what cost?
Okay, Chuck. Another question was, as far as the aerial versus terrestrial LiDAR, what is the kind of hotter market, or where are we seeing trends in those two areas? I know we directly do the aerial-oriented LiDAR, and then we have a partner that we work with regards to the terrestrial-oriented, actually mobile-oriented type LiDAR. And then there's also the terrestrial, which is the static-oriented LiDAR systems. But can you speak to the crossover between those and kind of where the market's at right now for those different types of LiDAR platforms?
Well, I think all three forms work the same way. They're all doing a point cloud of data. The high-definition scanners where you point, click, shoot, then you move it, point, click, shoot, move. So it gives millimeter accuracy, but it's really slow to be able to collect everything. The mobile scanning, you're able to drive at highway speeds and collect data, but you're going to do a swath width of about 120 feet either side of center at somewhere between 600 and 1,200 points per meter, depending on the number of sensors they use. The airborne, I'm going to fly at a 1-to-1 ratio, so at a 500 foot above ground level, I'm going to have a 500-foot swath. At 1,000 feet, I'm going to have a 1,000-foot swath ballpark. I'm going to fly to 60-degree field of view and have 20 to 40 points per meter. In a helicopter, in fixed wing, I'm going to do probably 8 to 12 points per meter. But there are things that the mobile scanners can do that I can't. I can't go on the underside of a bridge and be able to do an inventory assessment on the underside of that bridge. So I think the technologies all work really well together. As Josh said, aerial services doesn't collect the mobile scanning, but we've got a partner who does. So we would promote them on a project. If you needed wider than 120 feet, then the airborne LiDAR that we're able to provide is going to be great. Next question.
Yeah, we have a number of questions coming in now, so I'm trying to pour through them for you. Okay, so you kind of, I think you may have alluded to in that last question a bit, but how about the times where you might consider a wide area LiDAR versus a corridor LiDAR project, and what have we done as of late more so at our company, and again, where are the trends at within the profession as to a wide area versus corridor-oriented LiDAR projects, and speak to those differences.
The wide area projects, large block areas, typically are done fixed wing, whereas the sensor that we have is designed for small block or corridor areas. The large block areas are going to traditionally fly somewhere between 3,500 feet and above. They'll do a field of view of about 30 degrees. We're going to fly at 1,000 to 1,200, or 500 to 1,200 feet to collect the data at a 60-degree field of view. Flying in a fixed wing, you fly faster typically, so it's hard to get as many points on the ground. So it really depends on the project. The helicopter projects are traditionally going to be the corridor projects that are going to get the high point count. So if you're doing a power line, if you're going to do a highway, they used to want to do brake lines on only using the photography. With LiDAR on a corridor, at 20 to 40 points per meter, you may not need the brake lines because all the LiDAR is there. If there's a ditch at 20 to 40 points per meter, I'm going to be able to map the ditch. When I was only doing 3 to 4 points per meter, it was difficult to get the angle, and everything else was interpolated. So I'm giving you a much more accurate assessment. We've got partners that we work with that have sensors that would do a large block area, and those sensors work more economically than I could in a sensor that's designed for corridor mapping. So it just depends on what your needs are, and that's why it's really important that you work with your geospatial solutions manager to find out what the tool is. And all LiDAR is, it's just a tool in the toolkit. There are times that LiDAR is the perfect match. There are times where aerial photography is the perfect match. And there are other times where ground survey is exactly what you need. So it just depends. All we are is a tool in the toolkit. And I can't tell you that one is 100% better all the time. So it's real important to understand what your processes are, what you're using now, what you like about what you're using, what you don't like about what you're using, and what would you change. We need to understand as geospatial solutions providers what it is that your end result needs to be. And if I can understand what your end result is, I can come up with a solution based on those needs after doing a needs assessment. One of the really great things about aerial services, the hardest thing that we all do is get a signed contract. But anybody can do the data collection and the processing and the data delivery. Aerial services adds an extra step in that process where we do a kickoff meeting to actually understand, okay, this is what you said the scope of work was. This is what you said the projections that you wanted. This is the delivery that you want. Has anything changed over the course of our conversations? Because once we put it in that contract, that's what we're going to deliver to. And you know, 80 to 90% of the time, that signed contract is exactly spot on. But every once in a while, we get someone that will say, well, the contract says that you would deliver this, but this is what we really meant. So those definitions come into play, making sure that everybody's on the same page. There are times I've had to do a no-cost change order on a contract because somebody wanted it in state plane where they originally thought they wanted it in UTM. They wanted in meters instead of U.S. survey feet. So those kind of things can really change the course and scope of the project. So I really like that kickoff meeting. It also gives the geospatial solutions manager a chance to hand off the project to our project managers internally so that they're going to be able to give up-to-the-minute dates. So after I get a signed contract, I would hand off a project to the project manager, and they're the ones that are going to be able to give exact date and times, where I would have just rough estimates because things change on a sometimes hourly basis. And so they're going to be able to provide that where I couldn't.
Okay, Chuck, we've got a number of the questions I want to try to sneak in while we still have time. So the next one, you kind of alluded to it there a little bit with regards to the contracts, not only the contract, what we state in the contract, but can you talk about accuracy standards for LiDAR? And as far as you spoke to how we have a high view of accuracy with what we produce, can you talk to what kind of standards we use and how we will state that in a contract, so that we have one question here just generally asking about the standards, and another asking, okay, what specific standards do you guys use? So can you talk about both those things?
Sure. We typically, when we're saying that we'll meet 1 foot and 2 foot contours, we'll meet the National Map Accuracy Standards by SPRS to follow those guidelines.
Okay. Hopefully that addresses the questions there. If you have more, feel free to pop them in here. So we had a question about pricing, and we don't typically address specific pricing on these calls. That's what I was alluding to earlier. If you have any specific projects that you would like us to give you that kind of information for, you can feel free to let us know. We'll get that to you after the event. But could you speak to, in lieu of that, could you speak to pricing more generally, and maybe some of the factors that go into pricing that would be important for our guests to understand, Chuck?
Well, it's really understanding what the project is. It's like me going to a restaurant and telling a waiter, I'm really hungry. How much is lunch? I haven't ordered anything, so how are they going to know? So you can have project-specific where if you order the same project, we need to know the area that it's in. We need to know by having a shape file or a KMZ file, we know the location. We need to know what projection you're going to be using. We need to know the width you want the project, the length the project is, if it's corridor or a block area. We need to know how many points per meter. We need to know the grid spacing. We need to know if you want LiDAR and photography, how we're going to orthorectify the LiDAR, what we're going to orthorectify it to create the DEM. We need to know if you want bare earth. We need to know if you want a full feature, how you want that full feature broken down, whether you want the total full feature or if you just want key points. Key points would be buildings, roads, bridges, towers, water bodies, and how you want those, like the layers of the onion. Then we need to know other things if you're looking for intensity imagery. With intensity imagery, when I land, it takes me 30 minutes to post-process the data for every hour of flight, but I can hand people, after that, I can hand them the intensity imagery that's not geo-referenced, but it's able to help people that are trying to do, say, an oil and gas pipeline route or a power line route. They had us collect 1,000-foot swath, but they only may need 300 feet. I can hand them the intensity imagery of our flight. It's not geo-referenced, but they're going to be able to look at it and say, okay, this is the route that I want. So we may only process 300 of the 1,000 feet after that. When we collect the data, it's usually 48 to 72 hours for us to get GPS lock to be able to start processing the data. But those are the typical things that we're going to need. So I just need to know, what are you doing now? How are you getting your data, or how have you gotten it in the past? What are you looking to use the data for after you get it? A lot of times we provide data to customers. The LiDAR data is going to be way better than anything that they've ever used, because if they're using ground surveyors, the ground surveyor may get points of buildings where I can get the entire vector of the roof. The topography, we can get a lot more data on places that ground surveyors couldn't go. And it may sound like I'm speaking ill of ground surveyors. I'm not. They're another step in the process. We use ground surveyors for ground truth verification. If you're building a bridge from one side of a river to another, and you say, well, I came out 2.5 centimeters off, and that's the accuracy of LiDAR, that's not good enough. If you're doing plots of land and you want to know exactly where each plot of land is for a housing development, that's ground survey. That's not LiDAR. LiDAR is not going to be able to provide that. So there are tools in the toolkit, but I need to know what you're doing and how I can incorporate what we can do, not only for now. We're really a solutions provider, not just a LiDAR provider, not just an aerial imagery, not just mapping, but as technology evolves, we'll be in the forefront of that, being able to provide you those solutions. So that's why it's real important that we sit down and discuss your particular needs. You may not understand or realize that if you put a pipeline in an area with more than a 40-degree slope, there's a potential of a landslide in that area. Those are all things that the LiDAR is going to be able to provide you.
Okay, Chuck. Next question was with regards, can LiDAR support BIM-type applications, building-oriented applications, and how so?
That's the first time I've ever been asked that question, so I don't really know, but I can take a name and phone number and get back with you on that.
Okay, that's fair. Next question is having to do with, I think these are related as well. You mentioned MicroStation earlier on the kind of platform you're using for our processing. So what are some softwares, or can you speak to any more on processing and cleanup of this data? What does it take to actually do that? And I think a related question to that is, how do we generate the fly-through type effects that are popular with this LiDAR data, where you can actually zoom through this virtual model that's created?
Some of what we have is proprietary, some of it's off the shelf. As far as producing things from LiDAR, I said we use MicroStation, either TerraScan or TerraModel, or one of their suites of products. To output product, we can do outputs into typical GIS or CAD related. So if someone wants to know, they're doing say they want to move dirt, and they know they've got to move 100 truckloads, and they know that it's $1,000 a truckload, they get to the end of the project and find out that the way they were doing it, it's really 200 truckloads. That customer can't come to me and say that they didn't have money in their budget, because I'm sure that, or they didn't have money in their budget for LiDAR, because I'm sure they didn't have money in their budget for that extra 100 truckloads of dirt. With LiDAR, we're able to output it into AutoCAD or Civil 3D, and then the customer can actually do that that slope analysis or the cut and fill. With the LiDAR and what we're able to provide, there's a lot of different uses we can do in ArcGIS. We can do the change detection. We can set up a polygon after a power line's been flown to just process within a particular polygon and just do a change detection, or we can fly a levee, fly it this year and then in 6 months and a year, 18 months, 2 years, and determine if anything's actually changed on that. We can fly trees and do growth analysis for a power line to see when the trees are growing under what weather conditions. So there's a lot of things that we can do. And we use a lot of tools to do it.
Okay, well, so we're wrapping up here with our hour, and I've got one more question I think is a good one to end on. So in today's, speaking of tools, in today's tool chest there's a lot of great autocorrelation tools out there. And, here at Aero Services, doing orthophotography for many years, we've played with these tools over the years as well. But can you speak to, Chuck, if we're talking about a semi-global matching type technique or software, again, doing some kind of massive autocorrelation to derive terrain-oriented information in more photogrammetric ways from ortho imagery, overlapped ortho imagery, stereo ortho imagery. Why would you use LiDAR in lieu or in place of that? What are some of the advantages or disadvantages of either of those techniques? Here at our services, we do both those things, but as you were noting earlier, there's sometimes certain things work better than others. So why would you use a autocorrelated stereo terrain model versus a LiDAR-oriented model? Both have lots of points.
Right. In the LiDAR, you get the point cloud of data. So you're able to take that point cloud and take it to bare earth. So if that's a need, then it's real important to be using the LiDAR. The RGB value of the stereo imagery is not going to be able to go through a canopy to be able to see, say if you're mining a raw material and you want to see how to get it to a river faster and you're looking for tributaries, or if you needed to cut a helicopter pad, you're able to use the LiDAR in a bare earth model where in imagery that would be difficult to use. But we've been doing stereo imagery and modeling off of that since 1967. So there's just, it's the project specific. I wouldn't say that customers should use LiDAR 100% of the time or aerial imagery 100% of the time or even ground surveyors 100% of the time. It's all the right tool for the right job, and that's why it's real important to sit down with somebody and actually discuss what your needs are and then develop, working hand in hand with our processors, our flight operations people, to come up with the best solution possible for what it is you want to come up with, what your end result is in mind.
Okay, well, I think we got through the majority of the questions here, and there were a few questions there that we couldn't answer or that we deferred, and we'll get back to those questions later. So we'll definitely do that as follow-up. Just a note before you leave that we will have this presentation available within about a week or so as a video, as well as PDF slides of the slides that were presented here today. So you can look for that coming in your inbox shortly. And also, we'd ask you to please fill out the survey, which will appear as you leave the webinar today. So on behalf of myself, Josh McNary, our presenter, Chuck Boyer, as well as Amy Vossberg, who has been helping produce this event today, we thank you for coming, and we hope to see you again at next month's Aerial Services webinar. Again, visit aerialservicesinc.com/webinars to stay in touch and know when our next events are upcoming. Thanks again, and we will speak to you soon. Bye now.
Thanks, everybody.